So here we go. This is trying to figure out what happens to lambda when the frequency doubles and the medium's properties do not change. In other words, the speed stays constant. So here is the first proof. So, let's just call it proof 1. So proof 1, we are going to say that V1 is equal to V2. And using the principles that we have above, subbing in the universal wave equation, F1 is times lambda 1 is equal to F2 times lambda 2, making the substitution. Well, we also have something else that we know. Sub F2 is equal to 2 times F1 in the equation. So we're going to make the substitution that F2 is 2 times F1. So right here, we're going to put it in. So bracket 2 times F1 times lambda 2, and on the left side, F1 times lambda 1. Now remember, I want to figure out what the impact is on lambda 2, so I want to isolate this variable. So I have to isolate this variable by moving the 2 times F to the left side, but I like the unknown or the variable that I'm searching for on the left, so I'm going to move the lambda and I'm going to move this to the bottom. So now I've got F times lambda 1 over 2 times F1. Well, what do you notice what happens to the F's? Oh, one's in the top, one's in the bottom, they cancel. And now we have that lambda 2 is equal to lambda 1 divided by 2, but we don't normally like stating it like that. We like to sit here and look at it as lambda 2 is equal to a multiplier times lambda 1. So it's 1/2 is the multiplier times lambda 1. So now we figured out that, in fact, as the frequency doubles, the wavelength halves. Okay, so if F doubles, the wavelength halves. Okay, well, the brute force method, which is, a little bit more number oriented rather than algebra oriented, is as follows. And then I'll stop this video and I'll do another one. So with numbers. Okay, well, we go back to our original equation. V1 is equal to V2, and we say that F1 times lambda 1 is equal to F2 times lambda 2. Now, what we want to do is just say, oh, well, we want to change F. A good number to say, let F1 equal 1. And as such, because we want to double it, then F2 is equal to, oops, I'm already on the next thing in my brain, is equal to 2 times 1. Well, 2 times 1, of course, is 2. So we're going to make the substitution of those two things into our equation. So we have 1 times lambda 1 is equal to 2 times lambda 2. And of course, we want to isolate lambda 2 again. Take the 2 to the other side by division. And then we can write that lambda 2 is equal to 1/2 lambda 1. So, more number-oriented method, but it returns the same results. Okay?